Okay, yesterday we looked at law of sines, and now we're going to look at law of cosines. We use law of cosines to solve non-right triangles when two sides in the included angle are known. So this is different than law of sines. Law of sines, we did the non-included angle. So now we're going to do two sides and the angle right between them, or when you just know all three sides and you don't know any angles. So the important thing to note is that we use law of cosines only when we can't use law of sines. Law of sines is easier, it's faster, and so we tend to use that one the most. We just use law of cosines when law of sines will not work. And you can tell by looking at the three different formulas, it is obviously more complicated. Okay, one thing to note here is that if side C is out here, angle C is in here, out. That's what you're taking the cosine of. If A and B are what's here, then A and B are what's here. And then you just rotate through, basically depending on which angle you have. Okay, so you're going to kind of work these from right to left instead of from left to right. So if we look at our first problem here, I'm going to first, of course, draw the picture. So I'm going to draw a triangle ABC. I'm just going to label ABC. Angle B is 34 degrees. And A, which is across from angle A, so here side A is 11. And side C, which is across from angle C, is 14. That means we're missing side B. So hopefully you see very clearly we have two sides and the angle between them. That's when we're going to have to use law of cosines because law of sines will not work. I will quickly show you why law of sines will not work by trying to set it up. So you don't necessarily need to write this down, but this is going to show you why law of sines will not work. So if I do sine of angle A over side A equals sine of angle B, which is 34, over side B, equals sine of angle C, which we don't know, over 14. Remember, we need 3 of the 4 pieces here. So if we try to use this, well, we're missing this and this. If we try to use this, well, we're missing these 2 pieces. If we try to use A and C, then we're missing those pieces. So no matter what proportion we try to set up, we are missing 2 out of the 4 pieces, and therefore it won't work. We can't solve it that way. So that's why you can see that law of sines will not work, and therefore we have to use law of cosines. Okay, if you remember I said notice and start with what angle do you have? You have angle B. So let's go back and look. You have angle B, and therefore you're going to use this middle formula. Okay, so we're going to set this up, and we can start from right to left, like I said, by knowing we're going to end with cosine angle B, which is 34 degrees. And if angle B is over here, well, let me go ahead and write this down. So we're going to have B squared equals A squared plus C squared minus 2AC cosine B, because angle B is what we have. Okay, so B squared is unknown, so we're going to put that over here, equals A squared, which is 11, so 11 squared, plus C squared, which is 14, minus 2 times 11 times 14. Okay, when you're solving for this outside piece and you have everything in here, you're going to want to enter it into your calculator straight as it is, working from left to right. So if I pull up my calculator here, I don't want to mess around here. I want to enter this exactly as I see it. Okay, so I'm going to enter 11 squared plus 14 squared minus 2 times 11 times 14 times cosine 34. Again, make sure your calculator is in degrees. If you don't get the same answer as me, your calculator may not be in degrees. So that gives us 61.656, so 61.7. So I'm going to write in here, we found that B squared is 61.7. Okay, not B yet. We haven't found B. So a little trick in the calculator is we're going to square root, and we want to square root 61.656. So I'm going to square root answer. Answer is down at the bottom. It's above the negative symbol. So we're going to second answer, and it's going to go ahead and square root that. So 7.9. So here we get B is 7.9. So we're going to go ahead and fill that in. Okay, and we can go back and fill in all the pieces that we had originally. So we had angle B is 34, side A is 11, and side C is 14. Okay, once we used cosines, law of cosines once, now we have enough information to use law of sines throughout the rest. So if you fill in your picture, that will help. I'm going to go over here on side B and put 7.9. And now if you set up your law of sines, you should have everything that you need. So if we have sine of angle A over 11, sine of angle B, which is 34. Oh. Uh-oh. Okay, so here I've written out the law of sines for this particular problem. And I'm going to go ahead and first and solve for sine of angle A. So we're going to cross multiply. So you get 7.9 sine of A equals 11 sine 34. And then we're going to divide by 7.9, divide by 7.9. And so the sine of A equals this mess over here. So we're going to inverse sine of 11 sine 34 degrees over 7.9, and that will give us our angle measure A. Okay, so you're going to make sure you type in, make sure it looks like this. You're going to do 11 sine 34, sorry, inverse sine, 11 sine 34, end the parentheses after the 34, divided by 7.9, end parentheses from before the 11, enter, we get 51.1. So angle A is 51.1. And then to find angle C, we subtract everything from 180. So we're going to do 180 minus 34 minus 51.1 gives us 94.9. So angle C is 94.9. Okay, so this is side, angle, side, and you're always going to pick the one that's using the angle that you have. Okay, next example. This example is side, side, side. So we're going to first draw our triangle. So we're going to draw a triangle A, B, C, and we're going to fill in side A is 12, side B is 27, and side C is 20. Remember, the side goes across from the angle. Now, when you have side, 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 you don't have any angles, and therefore you can actually use any of these three. Okay, so it doesn't matter which one you use. So I'm going to go ahead and just pick one. And we're going to do a squared equals b squared plus c squared minus 2bc. Remember, that goes together, times cosine angle A. Okay, so I'm going to fill in the missing pieces, and I'm going to be missing angle A here. So I'm going to have 12 squared equals 27 squared plus 20 squared minus 2 times 27 times 20 times cosine A. So my goal here is to try to get this cosine A by itself. Okay, so in order to do that, what I'm going to do is, I think the easiest thing to do is write everything out as much as you can. So I'm going to write 12 squared, which is 144, equals 27 squared, which is 729, plus 400 minus, now I'm going to go ahead and do 2 times 27 times 20, and you get 1080 cosine A. So if you think of 1080 cosine A as a single term, like a 2x, that's actually what you're going to get by itself first. So we're going to add 729 and 400, which gives us 1129, and we're going to subtract that from both sides. And so we get negative 985 equals negative 1080 cosine A. Then we divide both sides by negative 1080 to get that cosine by itself. And we get 0.91204 equals cosine A. And then you're going to inverse cosine 0.91204, or inverse cosine your answer, which will give you a more exact number, and A is 24.2. Okay, so a lot of work when we're missing the angle. So angle A is 24.2 degrees. Side A is 12, side B is 27, and side C is 20. And we're not finished. So what we need to do now is find the other missing angles. And as I've said before, you are going to use law of cosines once. One time is all you ever need to get the missing pieces, and then you're going to set up law of sine. So we're going to say sine of A, which is 24.2, over A, which is 12, equals sine of B over 27, equals sine C over 20. And just because these are close together, we'll go ahead and do those first. So 27 sine 24.2 degrees equals 12 sine B. Divide by 12, divide by 12. And I'm sorry, I'm out of room. I'm going to go way over here. And what we have now is 27 sine 24 divided by 12 equals sine B. Okay, if we type that into our calculator, we have 27 sine 24, end parentheses, divided by 12. There's our decimal, and then that's the sine of B equals this. So we need to inverse sine the answer, and we get 66.2 degrees. So we get angle B is 66.2 degrees. We're going to fill that in. And guess what? We're still not finished. But the easy one now is that they all have to add up to 180. So 180 minus 24.2 minus 66.2 gives you 89.6 degrees. And that is using the law of cosines. So 2 examples here. If you can go ahead and work these out. Notice this one you have the angle, and then the 4th one you don't. So number 3 matches what we just did with number 1, and number 4 matches just what we did with number 2. So use those examples to help you through it. Thanks, and have a great day.